So we'll talk about the enterprise search engine. My name is Pawan Shah, and I have around 15 years of experience in product development and big data and machine learning areas, and that includes product in search domain. So I have developed at least three product in search area where I'm currently in life and working areas like full large scale search systems. So that's I have been working for the clients like Apple, Walgreen and Walmart, or those last 14 years. So that's about me. What are the agenda today? We are going to talk about uh, what is search engine. So introduction of search engine will talk, and then what is the search and discovery. What is the relations between search and discovery, and how these search and discovery systems are merging together. So, one of the example is in discovery systems is the recommendation system or recommendation engines. So how they are merging or how they are trying to collaborate each other. Then we will talk about search engine architecture like Google and Lucene architecture will talk, and then we will talk about search engine some of the use case that when you work in search area, then what are the use case generally you have or you have to implement. So some of the use case we'll talk about, and then we'll talk about how the machine learning and deep learning in the search. So how is this deep learning or ML is working in the search area. So how they are bound together, and then we will have couple of demos. So if you have any query, feel free to just either ask or chat in the chat window. So what is search engine, right? So then, I mean, there is a Google search engines, and that's very famous. That is general purpose search engine, where anybody come and search. That is called about uh, general purpose search engine. But here we are going to talk about is the enterprise search engine. When the same search you have to put in the place for whole the enterprise, just like you're on Google, you put in your organization. So that we call it enterprise search. And so what is enterprise search? To identify and enable right content to right user in right time. So think about that. How this is important. So you in the big data area or a big data domain, the way the data is exploding, you have a lot of data, and on the lot of data is producing every time with the different velocities and different veracity. But if you don't provide the right data to right user in the right time, right? So then you are not in the race. Actually. So we heard right. You heard a lot of things that data is the new oil, or data is the new key in this AI or machine learning area. But that is the half part of that. If you don't process and don't able to provide the search on those data, then there is no use. So the processing and the searching of those data is also important. Now, I think someone joined. So, so this is the search. I mean, this we'll talk about next 2 hours. What is the search engine and how we implement, and why searching is important. That we just talk about. If you have the data, but if you don't deliver the data to right users and right times, right time, I may say the latency is like if you have to be your search engine should be fast enough to to get the right data in the seconds or in milliseconds, whatever the SLA you have. And then now this data, I mean the search enterprise search is basically uh, is a collaborating three things that you have to be a right algorithm. So it's like this domain is going on algorithm design. then you have a lot of data to process, to index. So it means you have to do some sort of distributed processing, parallel processing, so big data, and then you have the scoring, ranking with your own way. How to score your data? I mean, when you search it, you have a lot of data. You search some queries, or some semantics you search, or some graph you search, but then you have to score it. You rank it, that which is the best fit. This is the best use. So then again, scoring involved or ranking involved. In search system we call it scoring. In the machine learning terminology, we call it ranking, right? So these things involve. So this covers. I mean, if you have to be good in enterprise search, you understand these three areas basically, and many more. When we talk about personalization, that how this user or contextual search that we're going to talk about, do you have to understand their user behavior or personalization of the system. So CRM involved. So not only these three systems, there are many systems involved. So you need to be control on all those areas. So search is hard basically. Search to building a search engine or implement a search engine for your organizations, for meeting all the SLAs and on all these volumes. It's hard. Why search is hard? Because your volume first, that I mean, the area we are talking about, the digitals, that you have a very high volume of data that need to be indexed and that need to be searched on. So the volume is high. Then varieties, you have media, you have images, you have text data, you have JSON file, text file, lot of files, different files, some schema files, some are not schema files, and some are text, some are visual. So this variety in the different media is coming, to be searched on. So that horizons have become larger and larger. And then in the speed, we are getting the data. It's like some are real-time data coming in the system, some are batch mode system. So that indexing part where you're feeding the system, feeding the data in the search system, that speed is also a role. So it's like velocity, the way your search systems is getting the data. Then query language, some system, some query you want to be processed in some of the REST services, some of the Python code, or some Java library. So the way you are taking the data, that language is query language you need to support also in multiple languages. So that is again, and that area is also bigger. So it's like how you going to consume the data, consume the search. Then query structures, maybe textual search or images, sound, map search. These are the different way you query, you structure your query. Then the context dependency, like you don't want to throw the same search result for all the users. So you want to have to understand the contextual. So in context, the search has been fired. It's like somebody searching on a form or on some other context sitting in some other country, and some their preferences are different than the other preferences. So you have to consider those things while dealing with the search, throwing the search result. So the contextual search or contextual dependency you have to be clear. So all this is the new word and new word that you have to take care. Then suggested support means sometimes the user not understand what they're trying to search it, so they put an incomplete query. So that then you have to understand the really mean what did they wanted to search, and then incomplete search, incomplete query to convert it your suggested support. So that's another area. Latency, that you have to research this search query result in within second or within microsecond. So those SLA, their latency there, though there's a volume, variety, everything is increasing, and then latency you have to provide. So you understand underneath what are the hardware you needed to support. Then access control, we'll talk about not general purpose, search engine. Here we're talking about enterprise search engine. So somebody need to be controller, some system need to control that how much information then comes, can searchable by some sort of user. So their access control involved while doing search it. So that API or that system also you need to plug in with your search system. Then compliance, some of the data is right that you don't want to searchable or mask it while you'll be searching for in the result. So there you have to certain compliance while doing with that. Then you have language or internationalizations. You have multiple languages, like somebody searching in the English, but your document behind the scene in some other language. So you have to convert those language and throw the result. Or maybe somebody searching in the language Chinese and you have a document in English, and then you have to convert those things and then get the document, right document, and then manual. So just like similarly. So the problem is, what I wanted to say is that search is a hard problem. When I say search means to facilitate all these dimensions and give the data and the right speed and the right time. Now, what are the solutions, right? So what is the way to deal with that? What is the ideal way to do that? So that we are going to study in the coming slides. Now, I'm taking to you some bit, see, when this Yahoo and the Google to search, when started, right? Yahoo, when built it initially, they stated like this, how they call it browsing system. So search basically categorized in mainly as a browsing and query. Browsing means you put it some category that you will see this screen, first screen I got it from Yahoo, like the Yahoo launched it, and uh, then you put it and then do category and then you go to search it. So this is the browsing, and another then the Google comes like the first screen I got it, the Vita Vision, that they call it querying system. So when you query, right, you put it some keywords or you put some boolean search, and then the system will throw the result on the basis of the query. So now you see the browsing systems is no more. Most of the things most of the search engine are the query based search engine where you query it. So now it did before the system organized the information of the structure, and the query was the Google. But what is the difference is that for the browsing you need to understand what was your structure. I mean, where the document is going to lie in which areas, right? So works well when the user is with aware or user wants to explore information and does not want to keyword to use and not some other area to search. But the query is across domain. It's like query can be works well when the user not know exactly what the query to use for the expressing an information. So that was the old. But most of the search engine we are going to talk is basically a query based search engine. And here we again more focused about the open search engines and how the open search engine works, because most of the time you implement all your features or the customizes that open search engine. One of the Lucene search engines, which is the basically Apache Lucene project, where is talking about basically text-based search engine, and then all these what we call it Elasticsearch and Apache Solr. They built up one, they use their search engines, and top of that they're putting all on their utility API or some sort of features API, and then serving or selling as a service. As you see Apache, Elasticsearch or Solr or Splunk or MarkLogic, they also have some sort of search users, but these two first, Elasticsearch and Solr, and then now it's a Google search, and that they now coming with something called Google Cloud Search or Amazon Search. They all are. Karan, do you have any questions?
Yeah, hi. So, Pawan, sorry to interrupt. Could you please tell what these scores are?
So this is the, this is the, I got data, data, this is the used up, how the, how they are, whatever the October, how they percently increase this number, how this search systems are ranked. So some company ranks for the uses of this search system. So it's like open source, how they what I would say, like how the companies are using or how the rank of this search systems by the users of that. So these ranks, this like Solr, Apache Solr was earlier higher, and then Elasticsearch is getting over. But we go the underneath how these things is working on, right? So we see a lot of Solar Cloud or Elastic Cloud implementation that you will heard it, or Google Search or Microsoft Azure Search. But behind the scenes, what is the working that we are going to learn about it?
So are you saying that Solr, Elasticsearch have higher rating than Google?
No, this Google search is not Google search that we talk normal. Google also sells, earlier Google was selling something called Google search appliances. That is a for company specific search, right? So it's not Google search, the normal,
Agreed.
whatever I put it is not general purpose of search. I'm not putting here. It's an enterprise search. So Google was doing that. They were selling a surface called Google Search Appliance, where they put in all the hardware together with the box. They are selling the Google Search GSA. We call it GS. One of the projects I was using it. So those things, they now have stopped selling these services anymore to the enterprise, and they moved this service to Google Cloud. They call it Google Cloud Search. So whatever Google you are relating, that is not here. Okay.
Oh, I see.
Okay.
Thank you.
So that is a different category altogether. General purpose, search engines like Bing or Baidu or Google, that is a different category. Here we are talking about the enterprise search engines. Okay, so it's like you are implementing this search system for your enterprise. So Google was selling one of the service for the enterprise. That's okay. So now we'll talk about how search engine works. Now, search is basically we have three components, three major components, and we will all we are going to talk about these three components in detail. One, that when you search it, you need a document. So one is called crawling. Like you get the document, so you have to go in different sources. So it's like your document, like in some maybe in Kafka systems, or some like in a relational database system, or some sort of flat file, or some sort of CSV file. So how to go data? This you can say crawling or maybe some sort of connectors for the enterprise. So this sort of connectors which go there get the data. So it's like Google has a crawler who go to the web browsers, I mean the web servers, and get you all the data and then build it. So crawling is the first piece, or we say it's connectors, data connectors, which goes to different system and get out the data. So that is the crawling. So you write your connectors when you build it to your search engine. You write your connectors, or you use some third-party connectors. Right? If you have to connect with some system that they provide connectors, you use it. So that should be distributed. Well, the whole things we are going to talk about is the one you can understand. So need to be distributed in the different machines, different, so like crawling or crawler or data integrators or data connectors need to be distributed so that you can have so many threads, so many data from the different sources and different speeds coming to your system. And then when you have data, then you build a data structure, right? Then you have a built data structure that we call it index building. Now you remember, right? If you have a data, right, how you organize the data so that you can get fast. You can search fast on that data. So we call it some sort of data structure building, or we call it index building. So two approaches there we'll talk about is called inverted index and the forward index. So, but for a time being, you understand that this is a data structure where you organize the data, whatever you collecting data. Again, before collecting or before putting this data structure, you do a lot of things, right? You do tokenize it. You have got a document, but documents need to be tokenized and some sort of metadata engineering you need to put there. So we'll talk. But you understand, you get a data, you need to put a data structures where you can have a faster retrieval of the data. So that we call index building. Index basically we talk two types. One is the inverted index, another is called forward index building. So some type of index you build, put your data. Then 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 you need to search it. So it's like you're firing search query, and then when the search, so some match happens, so some result will happen. Either text based search is a text search will happen, or semantic search, the semantically research, or image based search. Some sort of query you fire, and some matching things will happen. Now you have to rank it or score it. That suppose it's like 100 matching happen. How you know that this document have higher score or higher match than another one? Right? Which one is that? So what is the logic? What is the algorithm to identify this is the most fit or most matched document? So some sort of ranking and scoring is there. We'll talk about that, or relevancy, some sort of relevance. So when you tweak it, so you mean your organization is scripting, or you have to implement your own ranking because whatever the solutions or any other search engine there you don't want to implement. That is a normal one. But they give you like whoever the map, how many times of keywords there in that there is the best fit. But your requirement is something different. So you in all these three areas, when you have a use case, maybe you have to build it, or you have to whatever the open search, but you have to customize it. Index building, or before index building, you need for certain things. That's like, for example, you are building a semantic search, so like semantic search engine. Semantic search engine means, suppose I given a Java, I'm looking at something called Java developer. Suppose you are building for some recruitment agency, and then I also want, when the Java happen, I want that Spring developer, or some or JavaScript, or those areas also, because these are semantically linked. So we that also need to pop up, because though this is not free test keyword search, it is something that you have to build your own, because your whatever the solution search, either Elasticsearch or Solr, that both are the Lucene based search we are talking about. So it will not give you, they will not give you, like, they will not come the Spark developer when you are Spring developer will not come when you are Java developer you are searching. So those things either you need to put somewhere where index building, that Java means Spring also. So when you tokenize them and building this knowledge graph for index, then you put those type of things. So similarly, you understand that use case will change, or will ask you to change all these steps while implementing your enterprise search. Now we'll talk about your index. That data structure is important, right? When you crawl it, you put your data, organize your data in some sort of structure. So that here we are in the Lucene, or even Google, we use something called inverted index. Right? Inverted index means so suppose this, I have put an example here. Suppose these are two documents, right? You got a document D1 and D2, and this document has this something like my care is loss of care or something. Now, when you got to crawl this document, or this is a web page maybe, or you get this content from some CSV file. When you are putting the tokenization, before index building, you get it. Tokens are like my is one token, care is one token, and so on. So now you put it that. So my is it's something like, if you create a structure like my, and this is in document D1, and then care is in the D1 and D2. So and is again D1 and D2, and so on. So if you put sort of this structure, so suppose this is called inverted index. If suppose somebody needs to search on this, that they need a care, they put it keyword like care and gain, or care plus gain, or they were looking. So we'll find out where the care is that. So care is the D1 and D2, and so D1 and D2 qualify. First we'll identify both the words, and then gain is the where is the gain? So D2. So gain is in D2 and care is in D1, D2. So D2 is the matched one, right? So D2 is the matched one. So this way, you inverted index means your document, your keyword to a document. So this is, if you put other ways, hey, if you other ways, you put it D1 and then all your tokens, like D1 and then within the tokens like my, care and all these tokens. That we call it forward index. So inverted index is used in mostly, whatever you call this search engine, Lucene search engine, which is the foundation of the Elasticsearch or or Apache Solr or Amazon search or all these search you have to do. I mean cloud level search you have to talk about this. All the foundation of the index is done inverted index. Now this index is going to be used, right? You understand? So this index is going to be live on not one machine. With this data structure, either we implement it in some sort of map or hash table or B trade. So this is a use. This data structure we talked about is distributed. So it's like we have several nodes. So some part of this. So Google when implemented this something called big file. So this index is going to lie in multiple nodes and the multiple replicas there. Right? That is a big data problem. That when some replica is going down, some other need to be come up. So that is again other engineering. That is the data engineering. That how you put this index. Solution is the distributed search engine and says means you have to put this index in multiple nodes and then on some sort of primary and replicas and primary and secondary. So that is another way to look into this index. So is there any problem in understanding the inverted index? Okay.
So on a high level, what you're saying is that the documents that are crawled, the keywords are taken out, and every keyword is linked and indexed to the document, reference. And then when the search happens using the keywords, it essentially returns the document which has the most amount of those keywords. Is that
No,
right?
that is a very trivial way to see. I mean, very rudimentary way to think. But yes, you're right. That now this we'll go detail that it's not simple as the given here. It's not that all the document D1 and D2 will be there and we find out. Now this keywords will be many more documents, right? It's a many more document. Or think like this. Somebody put it in documents like big document. So it's like the keyword is care is 100 times. Some other is a smaller document, care is only 3 times. So it means that document, like whoever the bigger one, is always come first, right? So that is also not case, should be not case. Or who is only smaller document will get penalized. So this is a very I would say it's like a starting way to look the system. When we will go details, we understand the complexity. But to start with, yes, this way it works.
Thank you.
So I have a question. Hi, Pawan. This indexing actually happens after stemming, right? I mean, like things like done should be converted to do and like is to be. Is that?
You mean this conversion is something like while search?
No, I mean, does this indexing in Solr or in Lucene-based engines happen after stemming the words, like taking
correct. That's correct. Yeah. So first is that crawling. It's the crawling or connectors.
Okay.
Sometimes now this in our indexer is basically in Lucene. These are interlinked, so both they merge together. They call it indexer model. But you think like this, you get the data. So you think like Google. So Google write a crawl program, Python program, who go down different machines to get the data. So first you get the data or web page or document or anything. Now you need to parse it. So that is the parser or tokenizer or analyzer.
Okay. I see.
You got it token. Now here I put it the token is a very simple way, Mike here, because I just started. But you understand the is not going to be searched, right? Is now or off is not going to be searched. These are stop words, right? So
Okay.
then we put it some bit more complexity that we will remove that this token. So we call it stop words removal. So while index building, this index building, innovative index building, you need to play something, right? So, like removal of stop words that I don't want it, or stemming, like somebody losing, search is loss, and in document has something called lossing. So they come with the same word root, so that need to be also put. So while index building, you put that no, the word root is something similar, then index also together. Three times like loss and lossing is the same, or it's like they are just a different form of the word. It's coming the same word root. So while these are the things you play while indexing it, because while indexing, remember, any search engine is broadly has two things. One is the offline component or some sort of your index building that you have a bit flexible, and another is query part. Query is your SLA that if you don't deliver the data right within certain seconds or whatever we have agreed on, then you are not meeting SLA. But the index part, so some of the complexity you feel that if you put those in the query time, it will take time. So you can move those things, those in index time building. So I'm talking about, when you customize things for your own purposes, right? You're building in semantic search and you see that if I put semantics, parsers or those things in query time, it will going to take time. And I know that this use case is for semantic search. So I would put while index building itself. So those things is there, and we'll talk. But to put the ground to start with, I put it very rudimentary way to create index.
I see. Thank you.
Hmm. So here I was going to talk about. So I just decompose some of the things. That some are the offline part where you get the document through some sort of connectors, or maybe some bulk indexer is there that is like day zero you need to index. So it's like you have to going live and you have a lot of index. So there should be some bulk program. You write some Spark program or some distributed program, or a map reduce program to get your data, sitting on some sort of file system, or Hadoop file system or some other file system. Get all the data. So those things you can put those programs. Now start thinking like you get the documents through your connectors, or real time data is coming. Then you put it all of the things you're talking about, tokenizers, removal, streaming, all this data engineering, and then you create the index. This is offline part, and then you put a query. So suppose I search that Boolean search or keyword search, like I would search two keywords together, like both the keywords. So that is query part, and then how the query represents. So some sort of a query parser should be there. So which get your query input and then convert the executable query. Like Elasticsearch have their own way to understand the query, and Apache Solr have their own way to understand the query. But behind the scene, they all firing on the query engine that is losing this search. So some sort of a query representation is there, which is basically nothing. It's like getting the data and then creating the query for the system. Or some maybe you write your own plugin to SQL-like search a query that just like you're firing the query and search. So that's just sort of another model to write, getting the input and creating their own query plugin. And then you search it, and then some sort of similarity calculation will happen. You will understand what is similarity calculation. That how to find that two documents are matching, or how they closely it. So that's some sort of algorithms is playing for the scoring and ranking, and then you tune it, and then you learn it from the system. This way we're working it. So you give feedback to the system, and then you gone. So that this is basically very high level. So we'll go talk about few search engine architectures like Lucene search engine and then Google one. And then we'll talk about some advanced concepts. So this is the basically flow. You have a crawler, you have the document analyzers or metadata engines. You create here, you put your code. Now, if you work on Lucene and you have to customize it, Lucene is open source. You get the document and you write your own piece while you're bulk load or while index a part. And if you don't want to do that as it is there, then you can use as it is whatever the code there. Just like use their API and call this document and wherever the document sitting it and then index it. So they have something called bulk upload or bulk indexer and then like normal indexer. So you build the index, then you have query, you file the query. So again, then you have a query engine. If you want to manipulate their query engines, right? You don't want to manipulate their scoring engine, then you can write your own piece, plug in there. Otherwise, these are basically text-based search. So what I was saying that if you put it in a keyword and they retrieve the number of occurrence of that keyword in the document. So some random put it there and some fuzz the data and put in so many times that keyword, that will come to the faster because their scoring is trivial. With the scoring that the number of occurrence of that keyword and they will score it. So that is the ranking and then resulted. So I mean, if you have to customize your Lucene or your use case is that, then you can write your own piece on plugin all here. Otherwise, you can use their Lucene based API, either Solr API or Elasticsearch API to do these things if you don't want to change anything and just want to use it. So this is I guess this like Google first architecture. I put it here. A few very interesting paper is there. If you want to read it and you have time, sometime you read these papers. This is the Google first search papers, right? Like it's like when the Google started in '98, and this they talking about how the indexing is going to work it and how the crawling is working. So here you understand this architecture now that I just taken this diagram from there. That you have this crawler page. Let's go to there. So you have a crawler piece where you go to crawl, different web servers, get the document, and then you have some sort of some URL resolver that if not give the relative path or the absolute path, those sort of conversion, and then you put in the indexer piece, so where you really index those things, and then you need to search in that document. So searcher is there, and then you search on your index, and that's something they call it page rank. So this basically page rank is a scoring part. Right? I say that this will be requirement with your organization, that how you score it. Google say that I use something called page rank. Page rank is because this is general purpose software. Page rank they define as a function in that paper itself. That suppose your web page is X, and then it's referenced by so many other web pages. And suppose you are searching a keyword like iPhone. So if iPhone is whatever the page you are referencing, that also has an iPhone keyword. So you understand that how this iPhone, this graph, this page graph, the sort of graph they build. So it's like this document also have iPhone, but what the document they're referencing, they also have the iPhone and so on. And what they're referencing, they also have. The sort of chaining graph is built, and how many times they are referencing, they create something called page rank. And then page rank is nothing, is like the scoring engine part. So look at the page rank part is that you created your own way to scoring it. So when you match it, iPhone is matched so many times, you cannot display all the data, right? So how to score like top 10 or top 20? So that page rank is one of their algorithm to score it. Your organization maybe have some certain way to score it, Otherwise, the illusion is a default way that the text which is storing is already there. So there is a how many times they appear it, and then some sort of, we call it IFD model, that is the term frequency that we are going to talk. So how you calculate the term frequency and inverse term frequency and get the score. But this is the way Google, though there's a lot of change happen, but this is the foundations architecture is same. A lot of piece here, they're a bit advanced and then bit more distributed and more in the scale, but with the broad level, very high level piece come, on the Google search is this. Is this okay?
Yeah.
Now same diagram we put it in the component. Then this component look like this. We have some search server, so we have some sort of this component. We have a search UI, so you can think like Google search UI or any other where they typed it all this query and then they link it domain. Domain is nothing like your indexes. Like you want to search to fire in particular area only, CRM only, or this only. So it's like bit faster. Otherwise, you will search in all index, then maybe you will take more time. So if you know that I need to search in that particular domain at that particular index, that you are welcome. And then these are search servers where you say pre-processing. When you have get a query and I need iPhone, I'm searching iPhone, but you need to get a personalized that who's user who is going to be searched. So they some contextual signals to get it, or trace their cookies or their old history or how they search it earlier. So those some sort of some personalized signal you got it, and then you put it as semantics. Right? Sometimes that keyword is not expandable or not, that has some meanings on that. So you put it something like, oh, iPhone is some sort of mobile phone, or not other thing. Or like somebody is searching Java, so Java is a programming language, not in some sort of copy. So some sort of semantics you put it there, so that there is some sort of semantic analyzer or intent to find out those search. You put it and then structure that. You put it, expanded this query, then house order, canonical order, you put it this query, and then fire this query. And then while you get the data, then again you do some sort of post processing, which way you want to present the data. It's like you put it in some sort of JSON or some sort of XML or how you service this data, or some sort of page, paginations, or some language translation need to be put that you get the result, but the result need to be consumed by some other language. So some sort of that post processing involved, and then there's a result page where you actually display through some sort of UI. So this is the Google way to look into this. Look into the Google search engine architecture. Now I put it the Lucene component. Here Lucene is basically your opens. Either you work in Apache Solr or Elasticsearch or their Amazon search, or the foundation is the Lucene. Lucene search has the similar thing, similar broad level three things, but we have a different components like you have a request handler, like where you want to request you're searching or some sort of doing some admin task, and then we have a search component where you query and spell checking or suggesters or faceting, where faceting is like some sort of multiple filters together that filtering of the search result, or you put it that no, this keyword should be the part of on the prime first name, and this should be in this keyword should be other fields. So those are field label where you want to search it. So that some sort of multiple filters together you put it, or highlighting that when you search it, you want to highlight that search that and when the result comes you need to highlight that. So that is highlighter actually. Similarly, so these are components. Broadly this is again these are categorized in three parts. One top layer is you're building the index, index reader or index writer, or where you can, if you see this code, right? If you're interested, then there is a code and listen GitHub repository where you see this all the components, and if you have to tune it, you or customize it, you you can do your own way. Otherwise, there is already code available and you can use. What this Elasticsearch and Lucent, they use this library actually, Solr, and then top of that, put it their own utility API. Maybe you would say like the indexers, some more API like REST services. You will find some bulk upload API by some Elasticsearch or maybe Solr. You will say they support a different format, maybe a CSV document, or here they support only JSON. But these are, you understand, that before reaching to the search engine, these things conversion, and that they are selling as their product service, some sort of say USP when the Elasticsearch selling their services, or Solr or some other search engine. So it's like more of your boundary services or making more usable to the search engine, but the search engine component is like this. So here, suppose like you have a PDF or Word document. So here some sort of a API to parser API, like the Apache Solr. So you can convert it and get out the tokens out of that, get out the pin level entity mapping, and then you tokenize it. So some sort of a boundary. Before boundary, there will be some API you will see. Somebody asks you many times there was a difference when to use Solr and when to use Elasticsearch, and then what would be the answer? I mean, there underneath is the Apache Lucent search engine, but if you see the features what Elasticsearch and Solr provides, some sort of difference is there. So Solr you can document in multiple formats like CSV or PDF and other. Here you need a JSON documents in Elasticsearch. So you need to convert those things. You have to write your own piece to convert and get out the JSON and then index it. But Elasticsearch has other advanced features, sort of machine learning plugins, where you can tune your more relevancy in better way, and then Solr. So I would say it's like all have their pros and cons with the boundary API, with the utility way they look into that. It's like, but the search engines where they actually you build the index, inverted index, where you actually firing and getting the data. So this is the same. Okay. Some of the search use case, well, working in industry, you will say you have to implement like keyword search, Boolean search, that you understand what is the keyword search and Boolean search, like and or you put it like, and then keyword like two keyword or one keyword, and that is the default, like both the keyword you need to be there, or that is keyword search. Then a semantic search, like that I earlier talked about, that you need to understand the meaning of that. So semantically what that meaning, and then if that another meaning of that word is there, then you also search that. So that is semantic search. Then conceptual search is basically we get a one paragraph, right? One paragraph and you search it. Like keyword is not your one or two keyword. Think like you get a one job description that and you put it a whole job description and find out the. I'm taking the example of the recruitment search engine. So implemented your search for some recruitment or CRM, and then where you put a whole paragraph. Now somebody need to parse it. Somebody need to get out the meaning of the keywords, what are the keywords here there, and expand this. So that when you have some sort of big file search, I mean, when the search query itself is a file or some other source is not an actual keyword we're talking, this is called contextual search. Then contextual search is that you need to understand that who the users are, what is the context they are searching it. So what is their old history or what the circumstances they are searching those. So all those signals, context signal, and then you have to customize your result or scoring on the basis of the contextual signal you are getting for the users. So it may be possible the I search and you search for the same keyword, you will get a different result. And this is some of the things you have to implement that every time you should not get it. It's like should get a different result on the basis of my preferences. That is a contextual search. Then geo search, you understand that I want this documents of within 50 miles or 20 miles, and so geo codes like the coordinate need to be searched, longitude and latitude, and get out the document. So it's like geo-based search. Similarly, stemming language, stemming is like word root search. I would say is like if the two words are coming from the same word root, they should be search together. So same, if you put it one, the another also put. These all the search, and then language you understand, different languages search, ranges and filters. You want that, some salary need to be or some greater than 10 or less than 10. Those are filter or ranges you want to put in the query. So those are search on images or videos or highlighting, facet search or aggregations that start this acts in that set of fields. Y keyword should be that set of fields, and G should be under, and then you search it. So this sort of facets or aggregate search, and because otherwise you put it in all fields, right? So you can. So it's like if you're faceting it and aggregating that, this will go into different fields to search and get out of that. Auto suggest, you put it, something and search engine. So did you mean that? Right? Did you mean this? So that sort of auto suggest or spell checks, like put it three word, and it will auto complete, sort of auto complete. They understand what you're trying to understand. So they're trying to type it. Similarly, wildcard or regular expression you put, and then on the basis of like a star or single quote or all this regular expression based you want to search it. So these are the some of the search. Maybe you need to build your own, build your query your own way on the machine. So these are the use case. I mean, here I talked about the query based use case. That these are the search query based use case you need to support or you need to build in your application. One of the index build, file index, another is scoring we're going to talk about. But here the use case we are talking is the query based. So similarly, like suggester, you understand that like when you log in on the homepage itself, they suggest you something, right? So do you want to this link or you want to search this? Because they understand. I mean, you need to understand what your past search history, and on the basis of that, some link or something you suggest it. Similarly, Google they suggest you something, right? That similarly or more like this. More like this, like similar search or that you search, get the result, and then some sort of you go to shopping, they will show some similar result that you want to like this. So more like similar whatever result you're getting, and since you are accepting that search result, it means they understand that this search is providing you the relevant document, and then so they will do similar or more like that document. So those things have to that is one use case. Schedule search, that if you schedule that the search certain times, get the data, pass it, formulate, and then give top 10 results to me on email. Some sort of schedule based rather than interactive based structure. Then page ranking, scoring, that you have to customize it. That you will also feel when you work it. Many times you have to play your own scoring and not default scoring will work it. So that is also use case you work in the real projects. Then boostings and negative boostings by some functions. Like sometimes you give penalties, right? Then you want to normal scoring it, but you say that when this keyword is there, or when this keyword in this certain of document, certain type of document or some certain function you wrote, then you give a higher weightage, higher score to the comparison to others, right? So, or give a higher weightage to those section of document or those documents lying on those index or those departments. So those sort of you're twisting, some sort of boostings or negative, or give a negative boosting, that you boost your score on the basis of some your organization's logic. So that you also have to do that will play well. The scoring is built when you put in the ranking. Or you build a percolator search. Percolator search is nothing, when you search something like, you remember something site, you go subscribe and you search something. They send you a reminder that, oh, new items found or new items came in the index. So same thing. So you search, some item, some phone, you search it. The new phone with the same thing, they will alert you. So that is a percolator search is basically if you keep listening to index, that what you earlier search it, and if the new item for that point of time index that was not there, but after some time or that new document come for that percolators that you earlier search, this send you alert that new item or for these are the new documents new found it, so would you interested like that? So this is some sort of percolator's searches, right? You can relate these things on the real your shopping sites or some sort of job site. They send you these are the new jobs we got it for this week, right? For that, and they list it. So this is some sort of this percolator is running behind the scenes. Though you are not actively, it's not no real time you're searching it, but it's percolating all the new documents coming out that, and they will keep retest that those result is not already presented, already showed to you. Because that's the duplicate. So it's like new result is coming on delta index, and that show you. So that sort of percolator search. So this is one use case maybe you have to implement and the real project. Then search across multiple indexes. The index we will talk about. There's the index. Then is the index type or how the index are organized. So sometimes you have to search in one domain and one only two domains and or so those guys will search how many indexes you want to search it or across the organization index. These things you have to push. And then negative boosting you just talked about and search bit speech and images there that some just search it. I mean, give some voice and you give that some and then search on the basis of that. This is Alexa or Google Home works on that. So you put it your voice and on the basis of that they tokenize you're getting the token and passing your voice and getting the tokens and then put your do metadata engineering and fire the query, create the query, fire the query in the search engine and get the data and so to you. So these are the search use case you will work when you implement your own search engine. Do you have any query? Now we'll go to the another domain of the search. Is this okay? Hope I am audible. Can you hear me? Hello.
Yes.
Okay. So now we're going to talk about something more interesting. It's called discovery systems or recommendation engines. Now you see this search basically now is a bit what we talked about is not a new thing. It's like years, right? Years and only that search is nothing new. Only that is a skilled change, like the way and then high skilled and volume and other things is changed. But new things in search is something that is the same domain and we will call discovery. Now many times this happens that you don't know what you want to search it, right? So systems help you to search. You go to the site and shopping sites you say or movie site, they recommend you. These are the things for you. You don't search it, they recommend you. So that is again search, but there is some bit more that we are going to talk about. It's called discovery system. When you discover the information, and so recommendation engine is one of the one is a very popular discovery system or information retrieval or search system, and you can relate that how these everywhere you see this recommendation engines in place and either shopping sites or banking anywhere. Search is there, recommendation is there, right? Search is not really specific to any domain. It's everywhere. You will see the search. When your organization, either small or big, they have some sort of search, right? So some search, employee payroll search, or some sort of search. And then recommendation is something like a new thing. So within search. So we are going to learn about how this discovery system or recommendation engine. Recommendation engine is one part of discovery. So discovery system may have multiple things, but recommendation is one type of discovery system. So search is about finding specific things that either known or assumed to exist. That you know that you are searching iPhone, so you know either exist or not exist, maybe then it will give you no result. But discovery is about helping the user to encounter what you did not even know to exist. So you don't know that these are the sellers they are providing what you are looking for, right? So that is the discovery system. And search is like search engine or some database search system where you find some rows and columns. Discovery example is recommender system or advertising that you know to where to advertise or advertising systems whoever build it. So those are sort of recommendations. Where to recommend this product, which of the users to show that. So those are recommendation system or discovery system. Discovery is a superset, and recommendation is one implementation of discovery. Now we understand how this discovery system works and how this now it's like you say it's like search plus plus. The search is a bit more features and it's become a discovery system. Here is a machine learning or deep learning citizen pictures. How you identify that, how to recommend somebody, right? Or how to recommend this document or these items for this users. And how you know that this document you need to, if X likes your document, then Y also or Y also like your document, or Y also need to recommend it. So there is we are going to explore this area in next few slides. That we need to go on some concept of machine learning. So we'll touch few things in machine learning, and then we'll go to the how these recommendation engines there. So recommendation engine is how they're implementing this of the concept of machine learning. Machine learning, here we are going to touch about this, supervised learning. Machine learning is a big area, and we have some seminar, webinars on machine learning that you can attend. But machine learning is where you put some algorithms to either predict some score or classify a score that you never know, like some classification. So here we talked about supervised, so let's focus another way we lost it. So supervised learning is that that X1 related to X2, or X1 belongs to this group, or X1 has rank is some sort of score. But when the new document comes or Y1 comes, that never run that algorithm to get the score. That is a new document. How you put the score for Y? Because this is a new documents come, and you never your system never get that document. So you have some sort of training data, and where you put it your algorithm that how the X is getting the score or classify to some group. So suppose I look like this, I'll think like this. Usually buy systems, buy certain product, item 1, item 2, item 3, and you have a user and item database, and you trend that how the users are shopping it. So, but suppose new users come, that is not on your system, right? So how that sort of machine learning problem when your algorithms are not able to find, because if each data point, if the record document is coming, is a new way to look at. So there is not document 1 versus document 2. It's not like sequencing. You put the algorithms like go this step 1, step 2, step. So this is a machine learning. Here we are more focused on search is a supervised learning, that you already trained some of your data sets. You already have some certain data set you have available. You train your algorithms on that, and then new documents come. Then you have to predict that there is code or classify. Supervised learning is a two types basically. One is a classification and another is a regression. Regression is a continuously, you put some sort of a score. And the classification you group together that, oh, who classify this, in X document is where it classify, and then why it will where it be classified. So inference and generalization is the key. That how you generalize the documents, or how you group together, or how you infer it that is score. So that is the very broad level I touched. This, I know this is a very big area, and so, and here's very high level I put it here. But here's the things we need to go in the search system. Now, how the pipelines work in supervised. Here is more interested in supervised learning, because search, our discovery system uses this supervised learning. So you have some sort of document. So it's like a string, data set. So you have a text or document or image or sound, anything. So you get some features out of that. Feature engineering or feature extraction is that how these levels, you put what are the features, like you have. So that document has 10 features. That document is belongs to this department, or document has length is this, or this document has some sort of confidentiality. So mark it or unmark it, or some sort of security. So all those features that you put that document, and some rules that you get out, that we call feature vectors, or we call it term vectors. But this is a vectorization. So we'll talk about vectorization. You relate it like this. So if you have a document X and you have the 10 fields, now if you put it some sort of vector representation like that. Now, vectors, right? Matrices or vectors or tensors, where you put would represent that the term vectors. We call it term vectors. That's how the rows and columns you put it in. So you represent the document in a vector. Why vectors? Because what we are going to talk about is like how this document relates to others. So if you don't put in vectorizations, if you don't put in some sort of digitization, I would say, then how you calculate this? This is a mathematical calculation, that how two matrices or two vectors or two tensors are together, or how differences they are, how the differences between two matrices or two vectors or two tensors, what is the Cartesian product or cosine product, these things. So every document you vectorize it, and then you put some labels, put some sort of labels on the document, and then here your machine learning algorithm you write either classification or regressions, and then when the new documents comes, and then you predict test. Then you train on the test training data, and then when the new document comes, you get the features, and then this is your model, and you get the score. That is a basically very high level supervised learning pipeline. Now, this same concept we are going to use in the search and discovery system. So stop me, if I'm going too fast or you have a query. So you can go on details in any point you feel that you want to go details. So here again, here is a learning system or search learning system, basically discovery system. You see, still search and learning is and together. So here you offline doing this stuff you're doing online, just like in search your index building in offline, and online you do some sort of query. Here you model building or index building on some sort of data analysis you do on offline, and then you have your all this experimentation or data collections or those things that will keep going on offline and online both. Some data you get it offline when you train system, and some will come in online. And then you have a query generation, contextual pre-filtering, then retrieval, and then rankings that we are going to talk about. How you rank, it means the recommendation engine, how you rank that. When you recommend, suppose you recommend 100, but you cannot show that, So which is the best recommendation? Which is the best recommendation? So within that, some sort of ranking will be there. So that recommendation will be there, and then you display in UI. Now, this is here we are going to talk this red color, right, retrieval and filtering and ranking. So our all focus now we will talk about this piece. That how recommendations engine recommendation and score and rank and filters those things. So this is the area we are going to talk about. So this is the same. I put it in a bit more image that how this whole recommendation will come offline. What are the things will come? What are the online will come? You create your ML model in offline document. Put it plug in there in a scoring piece where you need to score and recommendation and filtering, and then your query will come as the representation function. Query, query will convert some sort of things that you need to fire that you get a recommended document, and this query needs to be auto triggered because somebody not triggering you. It's like some sort of auto triggered, somebody logging it, then need to trigger, or it's like schedule based trigger. So so this scoring you plug in, get the document, and then show it, and then out of that user select user accept it or user click on that. So you should get a feedback. You keep getting feedback that whatever your recommendation is the right recommendation in that. If not, then you always go to tune your model and get back. So feedback system is always there, here and there, relevancy feedback to going into their scoring plugin.
I have a question about the previous slide. Is it possible to kind of integrate the recommender system into the search engine?
Of course, yes.
So, like in I don't know, Solr or Elasticsearch. Can you give some information on how, what languages are supported, which one is better in terms of, support for plugging in customized models?
So that Solr is written in Java actually. So whatever you need to customize this piece when you see the Solr code, or Lucian code, I say. So where you create a query and firing the query, then don't fire the query and the search index. So you plug in your piece, whatever machine learning model written in Python or exposed as a service, as a REST service. You call that service with that keyword and give the recommended output or query expansion of query and then fire it. So this plugin I put it the red color is your piece. As a developer you have to paste it. Not Lucian. Lucian will not give or Elastic because this is a very scoring or recommendation is a very specific to that use case, that business case. So they given me one default way to score it. So it's like one normal, but every size, not fit everyone. Same size not fit everyone. So that is this. You have a scope to write your own scoring or relevancy or model either even Python or any other language and expose your service, and then your query will go there and get the data and then fire the document. So retrieval document, this piece, this red color that you can implement your own.
I understand, but then I'm basically asking because of this additional latency that if you first query from the search engine and then pass those results to the recommender model or whatever scoring algorithm you have this extra latency between these two services, and it would be really nice if I'm not sure if it's possible, but this recommender part be kind of part of the querying process from search engine. So basically, my question is which one of these search engines, these variations, have more support for, plugging in the models not as a separate service, just into the querying process from the search engine?
So your question is that what I understood is that which search engine provide you like this?
Yes. Which one has support for this? If
you look into the Solr code, Solr source code, right? They are putting sort of stuff in there here. They put it in this scoring piece and some sort of playing with that. So you just look into the Solr code source base, code base. right? You will get ideas where you need to plug, and then latency is there. It's always there. If you put a one layer, it is there. But this is all about how you put it. It's like you put it some caching, or there's like your machine learning model for that in. So that will be there. I mean, I'm not saying that you put in not latency, but your system becomes a discovery system, right?
I see. Yeah, I see. Thank you.
So this is this is basically search plus your scoring engine. So there is indexes where with the Lucian. Then Lucian also have the API to implement it. I was seeing this a few days back, or the Solr code, that is the 7 new version, and here they put it in lot of new API to implement that. You're putting your classification and regression models. So you will see that some pointers they already put it there in new versions to implement your own scoring for that. Now we'll talk about with Java inquiry.
No.
Okay. So a bit more about recommendation systems or discovery. That how you discover it, right? So there is two way actually. Two-way discovered with something called it collaborative filtering and then content-based filtering. So think like this. I'm giving very high level. This is the first these things, and not going into details of that. So think like this. Suppose I am the user of Amazon shopping site, right? And some you are also users, right? And I search some items there, and item 1, item 2, item 3, and then you also log in. You maybe your first time, and you're logging it, right? So, but since I'm my user profile, so some documentation is there. So some that you see the like my term vector is there, or my user vector is there, where is my profile created. So some sort of, and your user profile is also created. So which location you are, which is calling from, and all this some basics. Even your first time, you have some very basic things are there. So these things that how I and you are related. So what is the vector differences between my profile vector or my term vector and your term vector? And if they say these two vector differences, so there is many ways to find out the distance between vector, like one of the cosine similarity, Euclidean differences, Euclidean distance between two vectors, and many more. So basically, if these two vectors, it means two users are having very less distance or some sort of similar, then they assume that some sort of collaborative filter foundation is that whatever I purchase it will recommend to you also. So because user they think like user 1 and user 2 are related with some sort of distance is same or similar, and then they recommend what I purchased or to you also. So this is basically collaborative filter. We go how this works at very high level, because again then implementation of collaborative filter itself is again a big area. But very high level, this is a collaborative filter. What is the content-based filtering? I purchase something, right? I purchase some items today. So next time I will they will recommend it to me whatever I purchased last time, right? So it's like similar things will do. So what is not going to be other user, it's going to be whatever my personalization or what history I have. So that will be recommended on the basis of my content. So it's like or they like first time are coming, they have to some sort of guessing that what content is going to match. So it's like content based filtering that is not going to be similarity between the users. It's like users and items. And then a hybrid is some sort of both together. So some content and collaborative together, and then that is a hybrid based recommendation system. And then beyond rating and prediction, that's some sort of logic or filtering. You put it, or your organization you wrote that the recommendation is there, but I don't want to recommend these items or this document for that set of users. So some filtering on top of that will be there. Then scale and low latency will be there. We have to solve this latency problem. That how faster you can give process. So what are the infrastructure component you can put it. So those theories beyond, but beyond of recommendation, but it's a part of that. So that when you build it, you need to solve this two also. So some filtering or masking that you don't want to put confidential things, or your user don't have access of those things. No, you do not want to recommend. So although you have got a filtering out this X document, X number of documents, you put it some sort of filtering with the organization business model. So that is the not actual part of recommended, but is have to play in the recommendation. Collaborative filtering, I just described you to maintain maintain a database of many users and rating a variety of items, and then for given user find a similar user whose rating is strongly correlate, and then on the basis of that you recommend it for the similar users what I got it. Now what is the problem in this system? So it's like example is the Amazon's commercial recommendations is use this or some movie see this movie rating site. So that there's new movies come, you'll see how you get the scores for the new movies. Nobody going to score it. So some sort of that is a scoring. I mean, one recommendation you can use case is scoring. That how you predict that this new thing or new document, so what will the score out of 10 or out of that? So one is the and if it's the score 8 of 10, then you recommended some sort of that, some sort of users. So one is that scoring within the recommendation engine. So it's like new document, you score it and then you display with or that recommended some side. Another is that what is the new user comes. You don't have any things for that. How you recommended items for that. So all the commercial search engines, either Amazon's or any others, you say mostly they work on mostly which is broad percentage. It's like collaborative filtering. So Amazon is one of the examples. Collaborative filtering, I just put a diagrams, I think to understand. And so this suppose these are the user database. You have a and these so many users, and they purchase A and B and C, and these he has purchased C only, and these A, B, C is items basically. And then you see that when the new user comes, this is active users come. So they come with these features, A, B, and C, and then say A, B, C is a 9 and 3. So here are the users, the similar users, those have the same features. So like first users, right? And the first users has a 9, a features value is 9, and B has a 3, and another is the last one, right? That is like vector differences they calculate. So 9 and 10 they think is a closer. So is a 10, and then B 3 and 4 is also closer. And then these two guys purchased item G and right. So when the new system comes, they also recommended G for this user, right? So you see that their features with these features, G is they recommended these G items to this user. So some sort of finding the correlations between the active user, what are the new users and what is the user database, and then you recommend it. The drawback is that if you don't have a sufficient user database, right, then your recommendation will not work, right? Or you don't have a sufficient personalization data, then there's a problem. So this is the steps I put. So it's like you get to the rating, you vectorization because you calculate the difference distance between the metric, and then your user and then items. The filter. This phase one is a filter. That is basically collaborative filtering. That you get all the documents. Suppose this new user, you have 100, right? You have 100, all this filter it, whatever the condition fitted the y vector difference calculation 100. Now you cannot recommend it, or even 1000. No, you cannot recommend it. So then you have to put some sort of ranking or some sort of scoring. So what is the best recommendations? So then this is another step, like phase 2. So this collaborative filtering has one is the getting out the data set. What is the recommended data set? So you filter out all these algorithms, and then within that you rank it, and whatever the ranks top rankers, you recommend it. And again you tune it if you see that the recommendation is right, they click it. So there's some sort of click event you captures or mouse over or whatever, and you assume some logic that this is the right recommendation. If not, then again you keep tuning your model. What is the problem? The problem with the collaborative filtering that there should be enough users, right? If you don't have a user database, you're starting from zero, starting one, then I don't think it's going to work. Sparsity is like a very sparse way to represent. If there are many items to recommend it, even you don't have the same items purchased by many users, right? So it's like if the matrix is, the item matrix is a sparse matrix, then also you not get a right recommendation. Then first time, the first items is coming, or new items is coming, then nobody purchase it, right? No purchase it, then then again there's going to be problem in the collaborative filtering. And then popularity bias is there. That if something some item is purchased or item is by multiple users, or seeking a viral product, then you are biased to recommend for everybody, or though maybe they're not interested. So that you have to something called bias, popularity bias is there. And then here is the in the weight vector space model, you need to play this, how the popularity bias you need to mitigate it. That is something called we call it IFT. And the content-based recommendations, that recommendation based on the information on the contents of the items rather than user's opinion. So it's like you purchase that content, and then one content is related to another content. So find the items, vector calculations. You vectorize your items database or items record, and getting those. So it's like even the new items will come. So this item is related to some other item, right? You get out the cosine difference or Euclidean distance between two items vectors. And if that related, then your product, whoever purchased item 1, you recommend it. So this is some sort of a content-based recommendation. So these are three things you will see in any content-based recommendation, that you calculate how the similarity calculation. There's like two items, how they are similar. So there are multiple ways to find out. One is the nearest neighbor. Calculate nearest neighbor, the two items are related or not, or similar, or maybe some correlation coefficient, correlation coefficient you calculate, or some probability methods to find out two vectors are related or not, or even some API available. If you understand the NLP, some sort of glow vectors there, or some sort of vectorization is already inbuilt there. So it's like you have to just calculate the differences between two vectors, and some ready-made API available to find out the difference. And then feature representation is in the vector space model, that you understand that you have features for all the items or the users, and then you represent as a vector. And then is the term frequency. It's like how many times that term, so that is, suppose term is iPhone. So that item description have this iPhone, how many times, or there is a term frequency, you got it, or whole representative we call term vector. So term frequency is 3 here. But as I said earlier in search, that maybe you put it somebody fake it and put it item iPhone is 10 times in description. So that term frequency will be higher and they will get auto scores. You need to counter it. So you some sort of normalize it. So that is called inverse document frequency, where you normalize that scale, normalize it, and then together you calculate the differences like term frequency plus some sort of normalized inversely, and then you find out the score rather than, so that you not your model not come into stuck in that put it in so many times that that term in the description or another features. The topic modeling. So this is again a way to get the features, how to extract the features from this item or user document. Sorry. Am I making sense or?
Yeah.
So advantage of content-based system, you can understand that. So you first time or you're in cold start, then also you have something content-based search is work here. No first data problem. Able to recommend the user with unique tests and can provide explanation of the recommendation item by listing content feature. That is like item relationship you can have. Now we have 15 minutes. We want some demo actually. Let's quickly convert the slide and then we'll go on demo. So this advantage of content-based, that requires content that can be encoded as meaningful features. So if your content not enough or description or not, you're not able to find out the features out of that, then you have a problem for that. User test must be represented and learnable function to users. That also their test, right, also should sort of vectorize. So you have personalization, some sort of personalization available, and unable to exploit quality judgment over this. That since X1 is expert and X2 is following X1, so that is not able to exploit that, since the X1 is some sort of judgment. I mean, from the expert on that system on that recommendation, and therefore he's recommended, so other guy need to be. So that quality will be not there yet in content-based filtering. Overall, bottom line is that now search is evolving. Search and many times you will have a use case. Search plus you have to play with the scoring piece. You have to play this. So many times you have to implement the scoring, and for that you need to have hands-on on machine learning and deep learning. So these all this filtering and how you find out the features and how you score it. This in a scales actually. This is not a topical POC based machine learning model. Here we're talking on scales. Search systems usually in a scales, like a lot of data, and even not only training data, even the online you put in the system, the query is the way you have to match, and the number of queries, all this is the scale is important. So that is the one challenge that you will face, that the full pictures that you need to understand. That full picture of search is from, because this search is a big area. So somebody only working on the index building or that of tokenizer or streaming or put it some new features for there. Now in search part, they will write in search query, getting the data, writing API for the search and implementing. Then somebody need to be processing those data. Again, that is a big data processing, and then scoring. Somebody working in the machine learning area. So it's not like one team. So it's like different cross-functional teams, and they all are working together to find out the full pictures of the enterprise system or discovery system. And then one of the I would say challenges where many types of model they are within they are available in the lab or I would say sort of a research lab, but they are not tested in the skill that we are going to talk in search, right? So production, science to production is a very complicated. So that will always feel the challenge in the system. That how you scale, how you, I mean, from a small database in the some research or some papers that work it, but how this going to be scaled and how this going to be played the real life challenge. So you will face these things in your assignments. That is there, and scalability is hard in such system. I mean, when I say search means with discovery. So as you rightly said, because how you put in the latency, so then if you put a more component, you are going some penalty. So how you tune all these things, how you scale, how you put multiple components together, how you put your class, how you distributed, how do you distribute query, or how you query generations. Again, NLP API will be there when I will talk about semantics. How you plug together those NLPs that conceptual search I talked about. They give you the file to search it, and how you find the entity out of it, and which entity is related to whom, and how you precedence that this word need to be first search and then next search, or this word need to be searched in certain indexes not in there, right? Those intelligence you have to put, and remember, when you put those intelligence, you are putting penalties, right? Your processing will be slow. So all these things, and together you put in larger pictures, then you say it's not easy. And therefore, I first slide or second slide talked about search is hard. Search is hard to implement. When I say means, it's not that text search. It's like overall all the pieces together, all the dimensions on all together. You put that these things you will feel it. So the current trend, that few things are. I mean, the few current trends and few search. I put it here, but it's not exhaustive. It's like semantic based search and graph based search. You will feel that now graph is there. Not using search is text search, but the underneath maybe in graph, and you search like between two nodes and edges. Those graph based search you will feel, and then you see like the video searches, like you video based recommendation system. So you will see losing will be not solve the problem there. So you have to put something more. So your image based search, or speech based search, or video based search, or contextual search. Now, I implemented contextual search 2 years back for one of the customers, that they wanted to have you to get out the signals the way users searching it. So it's not throwing the same result for user 1 and 2 the same. So those things, now how accurate you are, right? How accurate you are putting the contextual search. So what is the way to find out the way user is operating it? Same user operating in some environment and some machines or some location, same users moving some other location, some other time, there you should be the result different. So those things is not I mean, talking with is like but easy, but not easy one to implement it. And these are the things coming in the search, and when you work in new search engine, these things will come to you to implement it. And so this is the new, but it's not all this. Some of these I have put it here. Current trend, but will be more. Have you anyone worked on search engine? Basically, implemented any search engine, either Lucian or Google Search Appliance or Amazon Search or or Elasticsearch?
I have worked with Solr a little bit. Yeah, and my current problem is basically recommendation, NLP-based recommendation. And actually, from your last slide, I was wondering, is there any of graph-based databases that you would suggest in terms of being more scalable, having more support for, I don't know, sharding?
Yeah, I also not worked on this, but I was just exploring all of the new things happening, and some of the new 4J they were talking about those inbuilt search that say they were of the graphs. But no, I have not experienced on graph-based search or not worked on that. Mm. Mhm. So also some. So I'm starting the something called Elasticsearch. So if you work in Elasticsearch and Solr, there is almost same. Only API you will see difference. And here I also start. So this is started Solr actually. This is a Solar Cloud. So this is working on 8983. So this is I was talking about this user, Lucene code base. So if you want to look it, you'll get an idea that how the scorings are better. They think they are placing new versions of the Lucene. So this is a Solar console and Elasticsearch. Elasticsearch doesn't have any console actually. So you have a API. So Elastic doesn't have any console, but you can have some other some third-party plugins to create a console on top of that. So this is basically just to start it. Now you say you learn about index, right? So you need to create an index. So and when you create index, then you need to put document on that index. Similarly in Solr or Elastic or anywhere or any Lucene search, even Google. So first you create index. So if you put it like there is many okay, so put it something like say demo one. So this is the index name, and if you so index, suppose index could be your organization name, and then index type is you can have a department type. So like so whatever you organize the index like there, then you can search in that particular index type also. So it says like domain, and I say Elasticsearch. So right. So the and so the first time either whatever are you putting the REST API, same thing you can do the Java API also. So you can write an indexes and create and write create index command. So your first time, so there is no in demo one or no index or no index type. If you put some document, the first time they find that there is no, they will create index out of it. So say something like my document is like this. And then say demo, this one is a field. So this is your document. Now if you related the indexer piece, whatever get the document and create document in JSON structures. So your reader or you know whoever the getting out the soaking the data from the different source, getting the data and create the this JSON document. So Elasticsearch. Other Solr you could have any format. So it's like a webinar. Right here. And then you say send. So just post it. It will create a document itself. So it's created. Now we want to search it, right? So there is a index called search. It's always created an index. So this is a search, right? Now, then similarly, you have put it, write a query, a bulk uploader, or you have put a lot of documents, and then you search it. Now you have a different type of search actually, a different type of query. So it's like you put your query here, that match is equal to this. You don't put it, means it will print off. It's like a searching. So here you put it the query, and then it will work it. So different types of query you will find it in that. Suppose here your search. Query, if you say match all, so it will click it, or you put it to match or something, that account name something. So there are different types of query. There's Elasticsearch, there are different phrase query, term query, and then filter, range, and all those things, and then sort, and then aggregation. Different types of search API is there. You see. So all this query you can have, you can find query. So this is just like SQL query, but not exactly query. But even when Elasticsearch has third-party plugin where you actually write your SQL-like query and convert it into Elasticsearch query in background and you fire and get the data. Now, similarly, in the Solr, this is your Solr console where you have a indexes, we call it collections. So there is 2 nodes in Solr Cloud, and here you have a document. Suppose demo is there already created. And then if you want to some index query, then you can get it here. And if you want to index it, put it some document, then you put it same thing. Here, if you want it the JSON document, here is a format they support it like this: CSV or file or in XML and other. You put it the document, and then you put it and it will index. And similarly, you will get query where your query is like this, and if you don't see anything, then it will query R. Right? Here is something like whatever the filter query you want, put sort or start. Sometimes you say start from 1 to 10 or 0 those rows, right? And then fill list what you want. So say I only want name in the return, so it will result only names. Right? And there's query parameters like what do you put it query parameter those. So same thing. This is basically you see this is a JSON, right? Created in JSON. If you put in a REST service, somebody you implement in your real project, you write some REST service to find out the query. Query builder will you give an UI that the screen some user type it, you get the data whatever type, create a query out of this query is equal to something, and all that different queries the Solr or Elasticsearch support, and then create the query and then fire on the search engine, get out, and then and so it's like this Elasticsearch also put your score also. So if you have more documents, this is exactly matching. It's happening to 1. Man means 100% match. Otherwise, if you not found, it's like I search it only Pawan and is not there, maybe some match there, so give you some score. So they score in on top of that sort on the basis of default is scoring on the basis of the score and then represent it and then display it. So this is you see this different types of queries also in Solr. So whatever types of query you can fire, at least whatever the use case I've gone through, all these things, most of the things you can implement to Solr or Elasticsearch query. These are all these we have talked about keyword and boolean and other sorts. Most of the search you can implement in Lucian without tuning your piece or implementing your customization piece. So that is there. We have we are time up. So we have a few more webinars. We are talking about machine learning and deep learning. In December, we'll talk about machine learning and deep learning using TensorFlow or PyTorch. we'll talk in January, and then we will talk about Python and NLPs in the coming months. So if you're not, registered, you can register. Feel free to register on these also, and most welcome for this. So I wanted to show some recommendation engine also, but some next time. Okay. How you implement recommendation engines? Any questions?
No, thank you very much.
Pawan, Srini here. Can you hear me?
I can hear you.
Yeah, actually, Pawan, are you going to share this deck or recordings to us?
Yeah, I will send you.
Okay, that will be great help. I think that was a good introduction session we had on this. Probably would like to see more on that, which you just shown that we'll be having more sessions coming months, so that we are excited to see that actually.
Yeah, I mean, I know there's a big area and a lot of very high level I touched it, but we have limited time, and now you can understand that you can more debug. I mean, you more good details of those topics, and then feel free to anytime my email is there. Feel free to write queries or any more details you wanted, so we can pick some topics and go there details. All these things, but it's high levels introductory part of we covered in 2 hours.
Sure, Pawan. Yeah, we will. I'll get in touch with you. I have a couple of things to ask. I'll talk to you later.
Okay, perfect. So thank you.
Thank you. Have a wonderful evening and good night.
Okay, bye.
Thank you, Paul.